This story is actually fulfilling one of the prime goals of the entire mission. Back 20 years ago when I first got involved, the reason that we wanted to have this whole telescope and NIRCam was exactly to discover these most distant galaxies. The NIRCam team joined forces with another instrument team called NIRSpec, and the idea was that we would use NIRCam to take images and then point NIRSpec at these candidates that we thought would be very distant galaxies.
The mid-infrared instrument had a hard time getting accepted on the telescope. People thought this telescope was designed to look at very high redshift objects, and the mid-infrared instrument would be hopelessly insensitive to do that. And so this is sort of a big bonus that, despite nobody expecting it, MIRI has made this big contribution to our understanding of the highest redshift galaxy we know.
JWST has 4 instruments on board, 4 cameras essentially. 3 of those cameras work in the near infrared, so just outside of what humans can see, to the red of what our vision would be able to see, and they operate from around 1 to around 5 microns is their wavelength of the light that they're sensitive to. There's NIRCam, NIRSpec, and NIRIS, and then the 4th instrument is MIRI because it's a mid-infrared instrument. All of the fancy, beautiful images that everyone sees from JWST, almost all of them come from NIRCam images. It's a beautiful, beautiful instrument. MIRI is a longer wavelength instrument, so it operates at longer wavelengths in the infrared, and it is a wonderful instrument, but it's not as sensitive. And it was expected before the launch of the telescope that MIRI would have a huge impact on science, but probably not on the highest redshift stuff, because things would be too faint to observe it.
The very first time that we took some images with NIRCam that were sufficiently long exposures we could find distant objects, we indeed found what was at that time the record holder, and this was back in October 2022. We had already decided that we were going to expose longer on this one area because we wanted to find something even more distant if we could.
JADES is an extremely deep view of the universe, a combination of 2 teams that came together who worked on 2 different instruments on the telescope. I'm the person in charge of figuring out the distances to the galaxies, just from the images alone. And so south of our initial observations is a region we call JADES medium. And as part of that, there was this one object that was really intriguing. When I finally had gone through everything and made my final list, I remember messaging grad student Jake Helton and saying, like, this is a real weirdo. It was a galaxy that looked, for all intents and purposes, like it was incredibly far away. It had a redshift of around 14 in those initial observations, only 200, 300 million years after the Big Bang. But it was really bright. And what I had seen looking at tens of thousands of galaxies is that as you go farther and farther away, the galaxies don't get brighter, they are farther, so they look a little bit more faint. And you look at, after you've looked at 10,000 galaxies, you've looked at so many little faint smudges just that you can barely, like, is this really something or not? So to have something this intensely bright was wild, and it triggered all of my skepticism sensors.
The process for finding these very distant galaxies is that you take a series of images at different wavelengths, and you try and build this spectra, or this rainbow of different wavelengths of light. And from that, you can find candidates for distant galaxies. But until you actually get the spectra and get these specific emission features, you don't know the distance for sure. I was looking with MIRI at what was unexpected for George Ricci and the rest of the people working on the instrument, which is looking at redshift 8 galaxies. So this is very, very far in the universe's past. And when I came to George, he was like, oh, you might find a couple of galaxies. I said, oh, well, I don't have 1 or 2, I have 22. 22 galaxies at redshift 8 that I can study and we can learn more about. And while I was doing this study of trying to find the most distant MIRI detection, I came across one of Kevin's very high redshift galaxy candidates. We thought it was at redshift 14. And when you look at the NIRCam and the MIRI images, it was brighter in MIRI than it was at NIRCam. And this was startling.
And so really when Jake came forward and said like, did you know this thing is booming bright with MIRI? Two things happened. One thing is that made me go, oh, it's definitely not a high redshift then. If MIRI saw it, it can't be, because MIRI's not the instrument on the telescope that finds and sees far away things. But then the other part of my brain did the math. Jake had done the math independently. The math had said, okay, hotshot, let's imagine it's close by. Then what's causing it to be so bright in MIRI? And the answer is, we couldn't figure out if it was at the low distance, the closer distance, there's not a lot that would produce that. But if it were really at the far distance, there was a couple very obvious things it could be. Oxygen, hydrogen, gas emission.
As I think about what it actually means, it gave credence to this very high redshift solution. It made, in my mind, it convinced me that maybe this was at the highest redshift. And if it was, it has profound implications for our understanding of galaxy evolution.
In early 2024, so almost a year after the discovery, the data comes down from JWST with the spectrum. And the first person to look at it was a person named Stefano Carniani in Pisa, Italy, member of the JADES team, and he works a lot on these spectra. And I remember him posting in the Slack channel saying, I think we've broken the record with the spectrum, which unambiguously showed it was not close by. It was, in fact, the farthest galaxy humans had ever found, confirming the predictions, confirming all of the things we had thrown away thinking that's too crazy, that's too crazy, that's too crazy, suddenly had all proven true. Here at the University of Arizona, the JADES team confirmed the current farthest galaxy humans have ever found, JADES GSC 14-0. It's like an archetype for the types of early galaxies we think might be in the universe.
We found that not only is it bright and distant and insane, it is also evolved. It is older than what we might expect for the earliest galaxies. I like to think of the work that we do as part of JADES and what I do as part of JADES as us astronomers kind of being like archaeologists. One of the goals they have is trying to find the earliest signs of civilization, of there being evidence for humans existing on Earth. And astronomers studying the universe were trying to find the earliest, the first galaxies and first stars that ever formed when the universe was very, very young. This effort with JADES GSC 14-0 is like you went and you found the earliest archaeological dig that you ever found. And when you unearth the dig, you find evidence that they're not going around with just sticks and fire. They're technologically advanced. Every time you find a more distant people, you think that they might be less evolved than the people that you found previously. And we've gone back in time finding these earliest galaxies, and it's not in the Wood Age, it's not in the Stone Age, it's in the Bronze Age.
What's the purpose? Why does it matter? Well, because it teaches us where we came from, and it teaches us the incredible value of life and the incredible preciousness of life. So when people sit and wonder, like, why am I here? Where did I come from? Well, you're here because a lot of things had to happen. That if they happened slightly differently, you wouldn't be here at all. Changing gas, simple gas like hydrogen, helium, into more complicated gas. Obviously, something happened in the galaxy that produced something that maybe is oxygen. Oxygen that you breathe right now required a star living its entire life and dying in an explosion. And we can see that because of telescopes like JWST.